Okay, so today we're going to see the difference between vector and magnitude. Vector is constituted with magnitude and direction. So where's the direction? This is the direction, and this is actually the vector, and the magnitude is the 5. It's like the quantity. That's what we have called magnitude. Okay, so the magnitude is that 5 that you see there, and then the direction is where the vector is going. So this is an example. So this one is the direction, and then if it was 2, and that's what will be the magnitude, and then this is what we got as angle. Okay, for example, you find the angle, and some example of vectors we see velocity, displacement, gravity, because velocity has a direction, displacement as a direction, and magnitude, gravity as a direction, because you're going to fall down if you are in the space. So in the ground is here, so the gravity, it's pointed toward the earth, the ground. Okay, you got force is always represented with direction. Okay, and then we got acceleration. Acceleration, you make acceleration into a direction. Okay, if you go left or right with acceleration. Okay, so that's what we see. Now, what is magnitude? Magnitude is the 5 that you see there. Imagine if I had just a line like this with 5. That 5 you see there, that's the magnitude, because there is no direction. So temperature is one of the magnitude, because temperature, you can measure temperature in a room without direction. Mass, everything that you see, maybe a box, that the mass, we don't have any direction. Volume, this volume that you can get. Speed is a quantity, so how much speed we're moving. We don't say in which direction, it's just how much speed that you need. And then the calculation of a magnitude, this is a formula that we use early, and in our case we use like R, something like that, resultant. It's the same as this formula that you see on top there. And then for your vector, this is how you represent vector. Remember, we saw early ux, yx. In our case, it was since we're working with u. In our case, we add something like ax, okay, ay, and then az. This is what we can use to represent vector A. In terms of unit, remember what is inside is unit, but what we got outside is actually vector. So these are just unit inside. Okay, so this is how you can represent a vector. A vector is a sum of units. So those units that you see there, I could just add them together. So be plus, and then I'm going to add here A, so I can zoom in. So just correct I think I made a mistake somewhere there. Let me just write it correctly. So it should be I unit plus ay j unit plus a z k unit. So this vector is how you represent it into 3D when you deal with 3D. And then if it was 2D, you were just going to stick to those two. This is how you can actually represent a 2D point. So this is a 2D. So all right, let's go to the next topic.